Hello students, today I am going to explain dimensional analysis. So this is the second part of the chapter unit and measurement. So as I have explained earlier that this chapter is very important for your NEET exam as well as JEE-MAINS. So let me explain what are dimensions, dimensional formula and dimensional equations. Now you see we have the fundamental or base quantities like mass, length and time. Now to represent mass we use the capital letter M, to represent length we use the letter L, and to represent time we use the letter T. Now any physical quantity you can express in terms of M, L and T with certain powers. Now let us take one example, say speed. So now speed you can express, you can write it is distance by time. Now distance means what? Length. So it is L, and for time we use T, it is T. So this you can write L T minus 1. Or here you see mass is absent, so you can write like this M0 L T minus 1. So here you see the power of M is 0, power of L is 1 and power of time is what? Minus 1. So here the powers of M, L and T are called dimensions. Okay. So what are dimensions? Dimensions are the powers of the fundamental quantities, okay, which are used to represent a physical quantity. These powers are called dimensions. And what is dimensional formula? The dimensional formula means what? This expression, okay, this expression is called dimensional formula. That is the expression used, okay, with the fundamental quantities with the powers, okay, to represent a physical quantity. That expression is called what? Dimensional formula. And the powers of the fundamental quantities are called what? The dimensions. And what is dimensional equation? Now here you see when this dimensional formula equated with the physical quantity. So here in the left hand side we have the physical quantity speed, in the right hand side we have the dimensional formula. So when a physical quantity is equated with dimensional formula, then this is called what? Dimensional equation. Okay, so for better understanding let me generalize this. For example, any physical quantity say X can be expressed as say M power A, L power B, T power C. So just I have given you the example of speed. In speed we have the power of M is 0, power of L is 1, power of T is what? Minus 1. I have already shown. So here this say equation 1, here the power A, B, C are called dimensions. And this expression M power A, L power B, T power C, this is called what? Dimensional formula. Okay. And this equation, so equation 1 here is called what? Dimensional equation. So I think it is clear now. When a physical quantity is equated with a expression which contains the fundamental quantities with certain powers, okay, then the powers are called dimensions, the expression is called dimensional formula, and the equation is called dimensional equation. Okay, now let me find the dimensional formula of certain physical quantities. Okay, so here I will give you the dimensional formula of some basic quantities which you have to remember. Okay, otherwise in calculations if you try to find the dimensional formula of every quantities, then it will take more time. So just to save your time, you try to remember the dimensional formula of the quantities which I will give you. Okay, so and also you will find the technique how to find dimensional formula. Okay, in fact they are very simple. So this is suppose a physical quantity. This is a formula. This is a dimensional formula. Okay, so first let us consider the area. First of all, you see, to find the dimension formula, only the thing is that you should know the formula of that particular quantity. If you know the formula, you can easily find dimension formula. It is very simple. So what is the formula of area? Area, you know, length into breadth. So length we use L, for breadth also use L, because both are distance. So here it is L square. So this also you can express in terms of MLT. So M0 L square T0. Here M and power of MLT absent. So then suppose volume. Now the formula of volume, you know, length into breadth into height. For length it is L, for breadth L, for height also L. So it is L cube. So this you can write M0 L cube T0. So you see it is very simple. Then say density. What is the formula of density? You know, mass by volume. For mass it is M. For volume you directly can use this one, L cube. So it is M L minus 3, or you can write M L minus 3 T0. Then suppose speed or velocity. Okay, so it is distance by time. The distance L, for time it is T. So it is L T minus 1, or simply you can write it is M 0 L T minus 1. Then suppose acceleration. So acceleration you can write your velocity or change in velocity by time. So you can use the dimensional velocity here, Lt minus 1. For time it is T. So it is L T minus 2. So this will be M0 L T minus 2. Then suppose linear momentum. Now what is the formula of linear momentum? You know, mass into velocity. So for mass it is M, for velocity Lt minus 1. So it will be M L T minus 1. Then suppose force. So the formula of force, you know, it is simple formula, F equal to ma. So mass M, A you can use directly here, L T minus 2. So it will be M L T minus 2. Then suppose pressure or stress. So you know, stress and pressure they are same. So for the formula of pressure, you know, force per unit area. So force, you know, it is ml T minus 2. For pressure, you know, for area, you know, L square. So here I already have given you. So it is M L minus 1 T minus 2. So here, so you see, to find the dimensional formula, it is very simple. Just you have to know the formula of that particular quantity. And you know, this year in 2020 in NEET exam, this question asked. Okay, what is the dimensional formula of stress? It is M L minus 1 T minus 2. So you see, it is very simple, and you get 4 marks directly within a 1 second you can answer it. So that's why this is very important, because questions which are asked from this chapter are very simple questions, and it takes only few seconds to solve it. That's why you should very carefully prepare this chapter, okay, without leaving any topics. Okay, now, so this is pressure. Next, suppose work. The formula of work, you know, it is force into displacement. So for force, you know, ml T minus 2, and for displacement it is L. So it is M L square T minus 2. So this is work. Then suppose power. So power, you know, work done by time. So work, it is M L square t minus 2. For time it is t. So it will be m L square t minus 3. This is for power. Then suppose torque. The formula of torque is given by R into F. R is radius vector, F is force. So radius also use L, and for force ml t minus 2. So this will be m L square t minus 2. So you see, we can easily write the dimensions, okay, just by knowing the formula of that particular physical quantity. So if you know the formula, you can easily find the dimensions. So these quantities are the basic quantities. So you just remember, try to remember the dimension formula of these quantities, okay. Others you can easily find out by knowing the formula of that quantity. Say surface tension or spring constant. So both have same formula, and it is given by force per unit length. So force you know, ml t minus 2, for length it is L. So it will be m L0 t minus 2. So this is for surface tension. Then suppose frequency or angular velocity, okay, same dimension. The frequency you know, 1 by time period, so you can write 1 by t. The time period means time, so it is t minus 1, okay. This is for frequency. Then suppose say kinetic energy. Now kinetic energy, you know, the formula is what? Half mv square. So here you have to remember one point, that you know this half is simply number, and the numbers, the numerical factors have no dimensions, okay, because this is simply number, it has no dimension, it is no unit. But here they are also you have the v square, this is also number, but it is not a numerical factor, because here what is the meaning of v square? Meaning of v square is what? V into v. So here the meaning of v square means what? V into v. It is not simply a number, okay. So you cannot neglect this power, but you can neglect this one. This is simply a number, it has no dimension, okay. So in order to find this, what you do, you just find the dimension of this only, because it has no dimension, you can neglect it. So for mass we use m. For v square, we know L t minus 1 whole square, so it will be m L square t minus 2. So this is dimension of kinetic energy. Then suppose acceleration due to gravity. That is g. So you know force, F equal to mg, you can write weight and force are same, we can use this. So from here g you can write F by m. Now for force you know it is m L t minus 2. For mass it is m, so it is L t minus 2. So like you can find the dimension of what? Acceleration due to gravity. Then suppose strain. Now what is the dimension of strain? Strain, you know, it is change in length by original length. Since both are lengths, so it will be L by L, so it is L naught. That means strain has no dimensions, okay, because it has no unit, so it has no dimension. Then suppose gravitational constant. That is capital G. So how can you find the dimension of gravitational constant? So use the Newton's formula. You know, F equal to G m1 m2 by r square. First of all, to find the dimension of any physical quantity, you should know the formula of that particular quantity, okay. So as this is the first chapter, in coming chapters you will get the several physical quantities with the formulas. So you can easily find the dimension formula. There will be no problem. For time being, we just using the formula. You just see here F r square by m1 m2. So here for force it is m L t minus 2. For r square it is L square, and m1 m2 is m into m. So it will be m minus 1 L cube T minus 2. So you see, we can easily find the dimensional formula of any physical quantity if you know the formula of that particular quantity. So here I only give you some basic physical dimension of basic physical quantities, because it is very simple to calculate the dimension formula. Since there is a basic quantity, that's why I am giving you. You have to remember this. Say impulse. To get the formula of impulse, the formula is force into time. Now force, you know, ml t minus 2, and time it is t, so it is ml t minus 1. So this is for impulse. Then suppose say electric potential. Now what is the formula of potential? Potential, you know, it is work done per unit charge. Now work done, the charge is not a base quantity. You convert into base quantity, means current. The charge you can write current into time. Okay. So here for work, you know, m L square T minus 2. Current you can use ampere A, or time it is T. So it will be m L square T minus 3 A minus 1. This is for current. This is for potential. Then suppose electric resistance. To use Ohm's law, we know V is equal to IR. So R will be what? V by I. So V is potential. Use this one. That is m L square T minus 3 A minus 1. I is current. You use A here. So it will be m L square T minus 3 A minus 2. So like this, you can find the dimension of any physical quantity. I think it is clear to you how to find the dimensional formula. So it is not here I cannot derive for all the quantities, because it will take lots more time for that, because there are lots of quantities, thousands to thousands of physical quantities. Okay, so just you follow the technique how to find the dimensional formula, so that you can easily find for any physical quantities. Okay, so this way we can find the dimensional formula of any physical quantity. Now as I have given you the dimensional formula of some physical quantities, now from here we can make a list of quantities which are having similar dimensions, because questions may come from here. Suppose 4 options are given, and you have to find in which options the quantities are having similar dimensions. Okay, so you can make a list of quantities having similar dimensions. Okay, so you can remember this list. The first we have, that is work, energy. Now energy means what? Any form of energy. Okay, it may be kinetic energy, it may be potential energy, it may be heat energy. Okay, any form of energy having the same dimensions. Torque, so there is having same dimension, that is m L square T minus 2. Okay, I have already derived the dimensional formula of these quantities. You can see the table. Then frequency, angular frequency, and angular velocity. These also have same dimension, that is T minus 1. Okay. Then you have Planck's constant, and angular velocity and angular momentum. This time also same dimension. Now what is the formula of Planck constant? You can use the Planck equation, E equal to h nu. So from nu is the frequency. Okay, so what about h? It is E by nu. So you can find the dimension for that. Energy, you know, ml square t minus 2, and frequency I have already given you, that is t minus 1. So this will be ml square t minus 1. Similarly for angular momentum, you can find out by using this formula. Angular momentum is what? mvr. You can put the dimension of m, v velocity l t minus 1, r is l, so it will be m l square t minus 1. So these two also have same dimension, that is m l square t minus 1. Okay. Then we have impulse and linear momentum. So this is m l t minus 1. Okay. Then you have surface tension and spring constant. So that is m L0 t minus 2. Okay, this is for surface tension or spring constant. Then suppose you have pressure, stress, energy density. They also same dimension, that is m L minus 1 t minus 2. They also having same dimension. Then suppose so these are some of the quantities having the similar dimensions. Okay, so you can remember the list: work, energy, torque, frequency, angular velocity, Planck constant, angular momentum, impulse and linear momentum, surface tension and spring constant, and pressure, stress, energy density. Okay, these are the quantities, some of the quantities which are having the similar dimension. Okay, now let me show you some of the quantities having no dimensions. Okay, they do not have the dimensional formula. So quantities having no dimensions. The first you have strain. I have already given you strain. It is given by change in length by original length. So both are L by L, it is cancelled out. Refractive index, you know, C by V. So C is speed of light in vacuum, V is the speed of light in medium, both are speed, so it is cancelled out, no dimensions. Similarly, we have dielectric constant or relative permittivity. Then we have susceptibility. Okay, susceptibility. It may be electric susceptibility as well as magnetic susceptibility. Both has no dimensions. Then you have relative permeability. So you will get all these. You will get all the idea of all these physical quantities in their respective chapters. Okay, for time being, you just try to remember this. Then okay, then you have suppose the permittivity, susceptibility, the refractive index, strain, displacement gradient. So displacement gradient means what? Change of distance with distance. That is called displacement gradients. Both are distance, so it has no dimensions. Okay. Then you have angle. You know angle theta. Theta is what? Arc length divided by radius. So both are L, no dimension. Now here, the most important thing is that you see up to this 6, these quantities have no dimension, no dimensions, as well as no unit. Okay, these quantities up to this 6, they having no dimension as well as no unit. But you see this exception. This is the exceptional case, angle. You know, it has no dimension, because L by R, so L by L it is L power 0, so it is no dimension. But you know what is the unit of angle? It has unit, that is radian. So this point you have to remember, that here you see angle is the only exceptional case which has unit but no dimensions. So here you can make a point. This is very important point. The point is that unitless quantity do not have dimensions. If the quantity is unitless, then obviously dimensionless. But dimensionless quantity may have unit. And only the exception is what? The angle. Because angle dimensionless but has unit radian. So this point you have to remember, that is dimensionless quantity may have unit. An example you can consider angle. Okay, it is dimensionless but have unit. But unitless quantity never have a dimension. Okay, so this point you have to remember. So unitless quantity never have a dimension, but dimensionless quantity may have unit. Okay, I think it is clear. So I have given you list of quantities having no dimension as well as list of quantities having similar dimension. Okay, you just remember this so that if questions come from here you can answer it. Now let me explain principle of homogeneity. Now principle of homogeneity means what? A equation is said to be dimensionally correct if the dimensions of left hand side quantity is equal dimension of right hand side quantity. Obviously, because any equation, suppose for example if I write y is equal to, say s is equal to ut plus half at square. So this equation is said to be dimensionally correct if the dimensions of left hand side is equal to dimension of right hand side. Obviously, because I put equal sign here, so whatever you add here you should get this. So these quantities must be of same type quantities. Okay, so any equation is said to be correct, dimensionally correct, if the dimension of left hand side quantity is equal to dimension of each and every term of the right hand side quantity, then it's said to be dimensionally correct. So this principle is called what? Principle of homogeneity. Now by applying this principle we have three applications of dimensional analysis. So here I will explain the applications of dimensional analysis. The first application is what? To check the correctness of an equation. Okay, so whether an equation is correct or not, we can check by the dimensional method. Now, in order to understand it, let me give one example. Say f into s is equal to half m v square minus half m u square. Now, we want to check this equation whether it is dimensionally correct or not. So what we have to do, here you see the left hand side is f into s. So for force, by the dimension I have already given you ml t minus 2. For s it is L, so m L square t minus 2. So here left hand side. Then you take right hand side. Here it is half m v square minus half m u square. So half simply a number, it has no dimension. Okay, you leave this. Then for m it is m, for v square the velocity, final velocity lt minus 1 whole square, minus here again half, you can cancel out m, then u square, use initial velocity lt minus 1 whole square. So here m L square t minus 2 minus m L square t minus 2. So it is m L square t minus 2. So you see in the left hand side dimension is what? ml square t minus 2. The right hand side also ml square t minus 2. Here you see, you have to only check the dimensions, okay? Don't cancel out. In dimensions, L minus L is not equal to 0, okay? It is not equal to 0 because just we have to see the dimensions of every term. Here this term has dimension ml square t minus 2. This term also dimension ml square t minus 2, and this term also ml square t minus 2. That is dimension of left hand side is equal to dimension of every term of the right hand side. So this equation is dimensionally correct. So we can check whether equation is dimensionally correct or not. So this is our first application, okay? So what you have to do, you have to just apply the principle of homogeneity and you have to see the dimension of left hand side quantity and right hand side quantity. If they are equal, then the equation is said to be correct. Okay, second application is to derive a formula. Okay, so by dimension method we can derive a formula. Okay, now for this again let me give another example. How can you derive a formula by using dimensions? Okay, say the centripetal force acting on a particle moving in a circle depends on mass, speed and radius. So derive a formula for force. Okay, so the centripetal force acting on a particle moving in a circle depends on mass, speed and radius. Derive a formula for force. Now what we have to do here, first you see what we have to derive. We have to derive a formula for force. So that you write in the left hand side. Then you put a proportional sign here. Then you have to see on which quantities it depends. It depends on what? Mass, speed and radius. So you write all in right hand side. M, B, R, all are in product form. It should be in product form, okay? Then you put the power A, B, C. In the next step, you equate and use a constant, dimensionless constant, M power A, B power B, R power C. This is equation 1, suppose. Here K is dimensionless constant. Dimensionless constant. Okay. So again I repeat, what you have to do, you have to see for which quantity you have to derive the formula, you write in the left hand side, and on which factors it depends, you write in the right hand side with powers unknown A, B, C. Next step, you equate with a constant and then you write the same. Now here, what is our main objective is find the value of A, B, C and then we put in equation 1, we will get the formula. So to derive the value of A, B and C, what you do, you just write the dimensions in both sides. For force, you know, ml t minus 2. K is dimensionless. For mass, it is m. For speed, L t minus 1. For R, it is L. So it will be m1 L1 t minus 2. M power A, L power it is B, and here it is C. So B plus C, t power minus B. This is equation 2. Now you just equate the powers of M, L and T and you will get the values of A, B, C. So just equating the power of M, L and T. So A, it will be 1. So A will be 1. Then B plus C, you can write 1. B plus C, it is 1. And then minus B, it is minus 2. So here A is equal to 1. So B is equal to 2. You put the value here. 2 plus C equal to 1. So C is what? Minus 1. So we got the value of A, B, C. Now these values you put in equation 1. So if you put these values in equation 1, so what we get? F is equal to K, M power A, B power B and R power C. So F is equal to K, M, B square by R. So you see, we get the formula. So it is very simple. What you have to follow? You have to follow the 3 steps. First step, the quantities for which you want to find the dimensional, you derive the formula, you write in the left hand side. Then the factors on which it depends, you write in the right hand side with certain unknown powers ABC. Then by writing the dimensional formula in the both sides, you can find the value of ABC. Then by putting this value in equation 1, you will get force. Okay? I mean, you get the physical quantity. So this is the second application. I think it is clear. Now the third application is to convert one system of unit to another. Okay, so by using the dimensional method, we can convert one system of unit to another system. Okay, now for that, what you have to follow, you see, any physical quantity, you can write any physical quantity, you can write x is equal to n into u. Okay, here, what is n here? N is the numerical value. And what is u here? U is the unit. Okay, say for example, say speed. Speed is equal to say 3 meter per second. So here you see, speed means here x, the physical quantity. 3 is numerical value, it is n here, and meter per second is the unit. Now if we convert the unit, say it is in SI, now if you convert into CGS system, then say meter, if you convert to centimeter, it will be 300 centimeter per second. Now here you see, if we convert one system into another, its numerical value changes. But overall the physical quantity does not change, because the meaning of 3 meter at 300 centimeter is same. So if we change one unit to another unit, it will not change the physical quantity. It remains same. So here you see, and in terms of dimension, how can you write like that? Here meter per second, it is you can write 3 meter per second means what? It is dimension of speed, ml minus 1. That means we can just write it like this way. Say if n1 and u1 be the numerical value in and unit in one system say, then x1, suppose we can write n1 u1, and if you write in terms of dimensions, you can write what? Here it is speed, so ml minus 1, it may be any quantity, so you can write say m1 power a, l1 power b, t1 power c. Similarly, if you convert another system, then you see the value of n will change and the unit will change, but powers remain same, dimensions remain same, because the same quantity for meter also L, for centimeter also L, so powers will not change, okay, but unit change. So here, if n2 u2 be the numerical value and unit in another system, then you can write x2 equal to n2, here say m2 power a, l2 power b, t2 power c. Now here, as I have told you, that if you change the unit, the physical quantity will not change. Okay, so we can equate 1 and 2. So you can equate equation 2 and 1. So what we get? n2 m2 power a, l2 power b, t2 power c, n1 m1 power a, l1 power b, t1 power c. So here n2 will become n1, it will be m1 by m2 power a, l1 by l2 power b, and T1 by T2 power C. So this formula just you have to remember. Okay. So you remember this formula, you can easily convert one system of unit to another system. Okay. So I will give one example, then it will be more clear. So this is the formula N2 equal to N1, M1 by M2 power A, L1 by L2 power B, T1 by T2 power C. Now how can you find the value of A, B, C? A, B, C you can find out if you know the physical quantity. Say for example it is speed. So here the power of M is what? 1. So A will be 1. Here power of L is minus 1. So here, sorry, it is not M. It is centimeter per second. It is LT minus 1. So here the power of M is 0 here, and power of L it will be 1, and power of time it will be what? Minus 1. So C will be minus 1. Okay, now let me give one example. Say convert 5 Newton force into dyne. So you have to convert 5 Newton force into dyne. Now Newton is the SI unit of force and dyne is the CGS unit of force. That means you have to convert SI unit to CGS unit. So first of all you write the dimension of force. What is that? M L T minus 2. So here now you write the formula. What is the formula? N2 is equal to N1, M1 by M2 power A, L1 by L2 power B, T1 by T2 power C. Now you put the values. Here you see 5 Newton. So here it is N1 is 5. Now M1 means what? Well, here you want to convert from SI to CGS. So in SI unit, unit of mass is kg, and in CGS unit of mass is what? Gram. What is A? It is 1. L1 in SI unit it is meter. In CGS centimeter. So it will be B is what? 1. Time 1 second. Here also 1 second. So C is what here? Minus 2. Here A is what? A is the power of M. It is 1. B is the power of L. It is 1. And C is the power of T. It is minus 2. So this power ABC you can find out from the dimension formula of that particular physical quantity. So here 5. Now 1 kg you can write 10 to the power 3 gram by 1 gram. That is 1. And 1 meter you can write 10 to the power 2 centimeter by 1 centimeter. And here it is 1. So this is 5 into this gram cancels, and this cancel 10 to the power 5. So we got the value of N2. So therefore you can write 5 Newton is equal to 5 into 10 to the power 5 dyne. Okay. So this way you can convert one system of unit to another. Okay. This is very simple. Just you have to remember this formula only. Okay. So I have explained the 3 applications of dimensional analysis.